Hi, welcome back. In this video, we'll be kind of revising something that I'm hoping you already know. We're going to look at characteristics of sinusoidal signals, and I just wanted to do this so that we are on the same page when we use certain terms. Okay, so what are sinusoids? A sine wave or a sinusoidal signal is basically a signal with a sine function or a cosine function. Okay, and you already know, I'm sure, that a sinusoidal signal can be defined by three different parameters. You have the amplitude, you have the frequency, and you have the phase, right? And the sine and the cosine waves are basically the same waves, but the cosine wave is a sine wave with a phase difference. It's shifted in time, right? And the shift in time is can basically be represented by this phase shift of pi by 2. So in so both the signals are essentially the same signal except for a phase shift. Uh, I wanted to talk about the concept of a lead and lag. So take a look at these two sinusoids. So you have signal 1 in green, which is Vm sine omega t. And the signal in red, which is signal 2, is Vm sine omega t plus theta. So when you have signals like this, one of the signal is shifted with respect to the other signal. And the way we talk about this shift is by using the words lead and lag. Okay, so we say basically signal 2 leads signal 1 by theta radians. Okay, so one way to think about this would be to say, okay, where does signal 1 reach a particular value? Let's say 0. It reaches at t equal to 0. At what time does signal 2 reach t equal to 0? Of course, it reaches it at minus theta over omega. I mean, you can calculate that. And therefore, it reaches the same point before signal 1 reaches the same point. And therefore, signal 2 is leading signal 1. Okay. Uh, Probably the easiest way to think about it is just look at the phase. If the phase is more positive compared to signal 1, then signal 2 is leading. Okay. So in this case, we are saying that signal 2 leads signal 1 by theta radians. Now, the same thing could be expressed in by using lag, right? We can say signal 1 lags behind signal 2 by theta radians, or signal 1 lags signal 2 by theta radians. So lead and lag are opposite uh, concepts. Okay. Now, the leading and lagging can happen. We could say that in here as in this way as well. We could say signal 1 leads signal 2 by minus theta radians. And that is the same as saying signal 1 lags signal 2 by theta radians, right? So if you're leading by minus theta radians, that means you're lagging the signal by theta radians. Uh, so hopefully that makes sense.